In this video we're going to talk about sine and cosine. Before we do that though, we have to review a little about angle measurement in radians. So what do we mean by a radian angle measure? Let's go up here to our unit circle. Its radius is 1 unit. If I click here, I will be picking out a certain angle. Usually we think of the angle as somehow being the distance between the blue line and the black line. But we can also think of it as the distance along the unit circle. And in this case, the distance from down here, this is where you always start your angle measurements, up to here is 0.88 units. In other words, if this is 1, this is not quite as far as that distance from here to here. And we say that this distance is in fact 0.88 radians, because a radius is 1 radian. So the distance from back here at the origin out here to the point 1, 0, that distance is our, that gives us our reference distance. That's 1 radian. This distance along the unit circle is 0.88 radians. Now what's the distance all the way around the circle? All the way around and back to your starting point. Remember the formula for the circumference of a circle, and that's over here, is the circumference is 2 pi r. So if r is 1, then the circumference of this circle is just 2 pi. So if we want to know how many radians there are, say, up to this point, well, let's go to here. How many radians would we have from, always start back here at 1, 0. How many radians, or what's the distance along this unit circle out to here? Well, the total distance is 2 pi, so this distance right to the x-axis here is going to be pi. Now if I click on there, I get close to being on the x-axis, and I see that my angle measurement in radians is telling me it's 3.12. If I got right on the x-axis, it would be 3.14, which is exactly a half of a cycle. Now just for practice, suppose I click up here. How many radians am I going to be showing? Well, that's half of pi, so it should be pi over 2. And I get a 1.56. And pi over 2 is actually 1.57. So if I can't get exactly where I want to be by clicking, but if I put pi over 2 in there, I'll see that my angle in radians is 1.57 radians. Remember what that means again. A radian is 1 radius distance. So that means the distance from here along the circle is 1.57 radiuses. Instead of saying radiuses, you say radians. And it really is a distance. If you had one of those little rollers and you rolled it from here to here, the distance on that roller would show 1.57. And let's get used to a few of these angles. So generally when you're talking about an angle down here, you call it a negative angle. So you start here and you go in the negative direction. So if I clicked right here, what's that angle measurement going to be in radians? Well, minus 1.59. It's about minus pi over 2. If I could get right on that y-axis, it would be 1.57. So I'm pretty close there, 1.58. So again, remember that's actually the distance. If you had to walk this off and the radius was 1 mile, you'd be walking 1.58 miles to get down here. And over here, if I go almost back to the y-axis, it's going to be minus pi. And again, why is it minus pi? Well, I know the whole distance around the circumference is 2 pi. So half of 2 pi is pi, and it's in the negative direction, so it's a minus pi. All right, now let's talk about angles that go with these different radians. Let me click up here. This is a situation we're used to. Okay, my angle here is 0.89 radians. Let me see if I can get close to pi over 4, which is, would be about there. 0.79 would be pi over 4 radians. I'm pretty close. So I'm about halfway between 0 radians and pi over 2 radians. And you always picture the sine as, well, this is the angle here. X is the angle in here, or the way we're thinking now, it's we visualize our angle by looking out here. X is the distance along the unit circle, and the sine of x is the magnitude of this leg over here. So the sine is always the up and down leg, and the cosine is always the left and right leg. So if I click over here, what's the sine going to look like? Well, again, it's up and down, and the cosine is left and right. Now, what are the signs and the SIGNs of these things? Well, the sign here is positive. It's pointing in the positive direction. And down here, the cosine of x is negative. Now, where is x again? X is this whole angle starting here at the x-axis and going all the way around to there. So it's some number bigger than pi over 2. In fact, this is what it is right here, 2.27. And the cosine of x, look down here, the cosine of x is a negative number. And you can see that in the picture. The blue leg is pointing in the negative direction. The red leg, which is the sine of x, is pointing in the positive direction. Now, what about if I go down here? How do you visualize the sine and the cosine? Well, there they are again. Sine is always up and down, and cosine is always left and right. And in this case, is the cosine a positive or a negative number? Well, it's pointing in the positive x direction, so we look down here and we see the cosine is positive. And what about the sine? The sine of that x is negative. And then finally over here in the, this is generally called the third quadrant. This is the fourth quadrant. This one up here and running along here is the first quadrant and the second quadrant. I'm down here in the third quadrant. What are the signs of my sine and cosine? Are they plus or minus? Well, let's click and see. In that case, they're both minus. Cosine is pointing in the minus direction, and the sine is pointing in the negative direction. All right, so that's the radius concept. And again, when I say radius, you can substitute the word radius for it. So this is saying the angle measurement for this point right here is minus 2.45 radians, is how you usually say it, but you can just also say it's minus 2.45 radiuses. In other words, you take this radius and you lay off 2.45 of them, you'd end up at this point here. One final thing, how do you convert radians to degrees? Well, that's simple enough. You just use a proportion. X is radians, so you divide by pi, and that will be 1 when x is pi, but we know that corresponds to 180 degrees, so that's the formula for degrees in terms of radians. Let's just look at a few of those. Suppose I click up here. What should the degrees be? It should be close to 90, and it is close to 90. What about over here, sort of halfway between 0 and pi over 2? What should the degrees be? Well, it should be close to 45, and it is. It's not bad. And what about over here? What is this one here? This one you don't see a whole lot. As I recall, that's 135 degrees. And there it is. Got it. And what about down here, halfway? Halfway, I think that's, what, 225? Let's see. No, it's minus 135. Yeah, because we got to go the negative direction. So if we made this x exactly minus pi, that would be all the way around to here. We don't want to go quite that far. We want to go times 3 over 4. And there we see that the degree equivalent of that is minus 135. We're looking right down here. All right, so enough about radians and how you express angles in terms of radians. We now want to look at some basic properties of sine and cosine. And this is what they are right here. And these are things that you have to be aware of. And do you memorize them? Well, sort of. After a while you get used to them. It's a good idea to know what the sine of minus x is and the cosine of minus x. In order to see that, let's look at this picture here. Here's x, this angle here, or in terms of radians, we look out here on the unit circle, and it's this distance from here up to here. The sine of x is always the up and down version of our legs, and the cosine is the left and right version. And we look at this, we can see the sine of x here and the sine of minus x have the same magnitude. These two triangles are actually congruent by geometry. If you recall, side angle side and side angle side, the magnitudes are all the same, so they're congruent. So the size of this is the same as the size of that, but one is positive and one is negative. So that's why I have this formula here. Sine of minus x is minus the sine of x. And for that reason, we say that the sine is an odd function. Not because it does strange things, but it's like the formula x or x cubed. If you take minus x cubed, in other words, you cube all of minus x, the minus comes out and it's minus just x cubed. So odd functions spit out the minus, and even functions like x squared eat up the minus. They disappear. Like minus x squared, the whole thing squared is just x squared. The minus disappears. So that's called an even function. And the cosine of x is an even function. You can see that from this picture. The cosine is always the left and right leg. And cosine of minus x and the cosine of x both have the same left and right leg. So we get this equality here. The cosine is sort of indifferent to the minus sign. It says, okay, big deal, I don't care. That's just the same as the cosine of x. So that's two of our basic trigonometric identities. So let's go back and look at the next one. Here's another one that's useful. The sine of x plus pi over 2 and the cosine of x plus pi over 2. Let's look at the picture that goes with that. All right, here's our picture that goes with that. Let me go up here to my figure 3. And I'm talking about an angle up in here now. So the question is, how does this cosine of x plus pi over 2 relate to minus the sine of x? Well, they're exactly the same. And to see that, well, first of all, how do you visualize x plus pi over 2? Well, you start here and you go pi over 2 and then you go x. So it's an angle greater than pi over 2. And the angle x by itself is just from here to here. I've taken a picture that used to be over here and rotated it. And this side here, the side opposite the x, is the sine of x. So the magnitude of this and this down here, which is the cosine of x plus pi over 2, the magnitudes are the same, but you don't want to, if you said it's equal to just sine of x, would be wrong. The sine would be wrong. And let's see that. Let's clear this up over here. If we look at the sine of x, that's going to be a positive number because our x is something our x really has to be over here. It's a little confusing. Our x has to be over here, then we add pi to it. So the sine of x is positive, but this cosine of x plus pi over 2 is negative. So they're going to be the same magnitude, sine of x plus pi over 2. Look, same magnitude, but different sign. So to get the equality in there, I have to make this a minus. Okay, now they're the same. All right, let's go on to our next basic property, which is, well, the cosine. You can say the same thing with the cosine. If this is x, then the cosine of x you can visualize as this little leg back here. the cosine of x is this, but that's the same as this up here, which is what we're calling the sine of x plus pi over 2. So we have this equality. If we have the sine of x plus pi over 2, that's that's 0.7351, and that's going to be the same as the cosine of x. Same thing. All right, so that's another useful identity. And why is that useful? Let me just say a little bit about that. Let's go over here. This is our answers here. That's useful because it shows that sine and cosine are very intimately related. One is some translation of the other. So if you know something about the derivative of sine, you're going to know something about the derivative of cosine. That makes it possible to prove something about the derivative of sine, and then you use these identities to prove something about the derivative of the cosine. So it's a very useful identity. And what about this one? The sine of x plus pi is minus the sine, and the cosine of x plus pi is minus the cosine. That's easy to remember. You know, when you add a pi inside here, it's the same as sticking a minus outside there. And let's see why that is. We'll look at this picture again. You know, x by itself would be up here. You'd draw a line from here out to here, and x would be here. So when you add pi to it, you flip everything around. That means this used to be the cosine of x, sort of down here on this leg. When you add pi to it, it flips it over here. And the same with the sine. The sine used to be running from here to here, but you flip it over. Now the sine is the same magnitude, but it's going in the opposite direction. So that's why we have these two identities here. And and this one here. So they're easy to remember. If you see a pi there, you just turn it into a minus here. The hardest one for me to remember is this one here. Not that one, this one here. And the way I remember it, or try to remember, I don't really ever remember it, is I remember this red line here. You know, that's definitely in the negative direction. And this down here is the cosine. So I just remembered that one. The cosine gives you a negative. The cosine ends up with a negative sign. Whereas over here, the blue is the same for both of them. They're both positive. So I just remembered this in my mind. I try to picture the red there whenever this sort of a question comes up. So let's go back and look at that one more time. I'm going to ask you these, and sort of quiz time. So if you want to think about it, stop the video and write your answer down, then I'll write it down here. All right, a hint here, sine is called an odd function. It's like x and x cubed. And what do odd functions do? They spit out the minus sign. So that's going to be minus sine of x. All right, what about the cosine of minus x? That is an even function. And what do even functions do? They eat up the minus. We can actually see that up in this graph here. Let's look at the let's put in here the sine of x as the red graph is the sine of x. And let me put my test. I don't even want to see the test right now, so I'm going to make that 5, so it's not even in the picture. And let me put my x to 0, so it's sort of, I'm going to put it to 10, so it's not in the picture either. Well, let's put it to 20, so it's not in the picture. I just don't want it obfuscating things. All right, this is the graph of the sine of x. And you can see how it's like x right here. You know, x would just be sort of a straight line up and down. That's the shape of odd functions. And also you can see how if you go in the negative direction, there's a symmetry here, but it's a negative symmetry. If I go this direction, it's sort of like going this direction, but here the sign goes up and here the sign goes down. So this is sine. It's an odd function. And let's go put the cosine in there. and see how that's an even function. That is like x squared. You know, x squared graphs is a parabola. It's sort of like it's like x squared here and minus x squared here. And you can see the evenness here. If I move in this direction and then go up, I get the same thing that I get if I move in the negative direction and go up. So the cosine is an even function. That means it eats up that minus. It just doesn't pay any attention to it at all. So that's the cosine. All right, now this one. All right, this is the one I have trouble with. And remember, remember it by saying one of these things has a negative and one doesn't. And they both get translated into the other thing. That's what makes them useful. The sine is related to the cosine. So I know this thing over here is going to be the cosine of x. Otherwise, this wouldn't be a very useful statement. And is it the... Oh, and this one here is going to be the sine of x. And then finally I say, what about that negative sign? Where does that go? Well, remember I focused on just this thing here, the sine of x plus pi over 2. Or no, actually I focused on, see, I never remember myself. Focus on this thing here. The sine of x was that red bar. It was a red bar in the negative side. So it's this side should be equal to minus the sine of x. And I could probably get that wrong. So I don't think so. Let's see what the program says. The program should have a memory, or it should know what that is. So I go to my conditional ops and look through them. And I have the cosine of x plus pi over 2. There it is. It's a minus sign. So my little technique worked. And I'm going to look at that picture one more time. I don't want to flip there now or I'll lose this. And now what about this? Sine of x and the cosine of x. Remember, they're the easy ones. They're easy, so what do they become? You're just, let's go to this picture here. Here is x, and look how blue and red, they're positive. If I go down here and add pi to x, what happens to them? They're the same size, but they both got flipped over. So this is actually equal to minus the sine of x. And this is minus the cosine of x. And now what about this one? Well, this one is very easy. If you have x here, and you go 2 pi all the way around the circle, what are you going to end up with? Well, you're going to end up with the same thing you started with. Sine of x, and this is the cosine of x. So again, do you have to memorize these things? Well, probably. It doesn't help. Certainly be familiar with them, especially be familiar with these here. You know, this is very useful when it comes to proving things about the derivative of sine and cosine. You do it for one, you can get the other for free, so to speak. Let's look at one more time at my problem area, which is this one here. And I got to go to figure 3. And here, you know, if I over here, ooh, I got my colors the opposite here. That's too bad, but that's the way it goes. This is what I remember. Minus the sine of x is that red line. So whenever I'm confronted with a formula with a cosine in it like this, and pi over 2, I think, well, this is a useful equality because the other counterpart has a sine in it, and it's on the negative side. This x, if you just took the sine of x, it'd be a positive number, but this thing over here is definitely a negative number, so you got to put the minus in there. So what else do we want to say about this? Probably not much. But let's just practice a little bit one more time. Now, here's some values for pi over 4, pi over 2, pi, and 3 pi over 2, and just a little radian practice. If I click right here, what angle am I talking about in radians, and what angle am I talking about in degrees? Okay, if you don't know the answer, stop the video and think for a second. I'm going to get approximately 0.80, which is pi over 4. You know, if I could get right halfway between them, I'd get pi over 4. And what is that in degrees? Well, remember what you have to do. You have to take your x and you have to divide it by pi and multiply it by 180, and it's 45 degrees if we were right there in the middle. And one more thing. What if I'm way over here, very close to the y-axis, but not right on it? What's my angle measurement there? Well, if I went all the way around, it'd be minus pi, and pi is 3.14, so I'm almost there. It's minus 3.11. And notice what that is in degrees. It's almost minus 180. So it all makes sense. I think that's all I want to say. Let me think about this for a second. All right, in the next module, we're going to look at some more complicated trigonometric identities. Again, the reason we're looking at these is, first of all, sines and cosines show up every place in physics problems, and so it's important to know what the derivatives are, and important to have some sense of what the sines and cosines mean, and where they're positive and where they're negative. So that's enough for this.